Hello everyone, good morning and welcome to today's webinar session, Artificial Intelligence for All Part 2, Mastering Machine Learning and with Neural Network. My name is Vilasini, or you can call me Nan. So today I will be your moderator for today. Before we begin, they have a quick housekeeping note. Oh, it's not working. Can you share it for me? Okay. Yeah. Okay. So today we will start with the housekeeping notes to make everything run smoothly. So before we begin, this section will be recorded and shared later on our YouTube channels. Please keep your microphone mute throughout the session unless you are invited to speak. And you can use the Q&A function and anytime to submit your question here. And you might also use the right hand button if you would like to ask the question directly. So today we excited to welcome back our speaker. So our guest speaker here, the first one we have Dr. Adi Monuwan. He is the AI researcher at SIIT Thammasat University, and he passionate about smart system and applying AI to solve real-world problems. And Dr. Adi, he is a specialist in machine learning, multi-agent system, and predictive modeling. So the next one, we have Dr. Talik Shah, who is the data analyst and automation expert from Connect and Akilab AI USA. He has been actively involved in AI projects across both industry and academia in Thailand and US. So Dr. Talik focused on demand forecasting, optimization, and automation using AI. So in today's session, they will help us to dive deeper into the machine learning, especially focused on the neural network, a powerful technique behind the many model AI application. So we will explore how classification and regression work in supervised learning and key algorithm like linear and logistic regression and the magic of AI neural network or ANNs. And yes, we will even have a hand-on demo showing the training validation and performance evaluation using the real-world data. So whether you are the beginner or just the curious, this session are designed to be appropriate, like practical and more fun. So let's explore how the neural network and are helping us to shape the future, including way we work, learn, and interact with technology. So please welcome Dr. Adi Monuwan.
Good morning, everyone. I'm Dr. Adil, and thank you, Nan, and thank you, HiTab, for inviting us here today. And welcome to our second part of our session on artificial intelligence for all. And today we will talk about machine learning and deep learning, and especially our focus will be on neural networks. And I will try my best to keep things simple so everyone can understand. So let's get started. Let's have a quick overview of what we will explore today. Actually, we will begin by understanding regression and classification problems, which are the two of the most common types of machine learning problems nowadays. And then we will look at how machine learning is different from deep learning, and where actually the neural networks come into the picture. And after that, we will discuss how neural networks actually work, how we can train them, and how the structures are connected to the neurons and give us the useful information. And we will also discuss about the optimizers and why we need them, why we use them, and what type of optimizers are available nowadays. And next, we will take a look at some popular Python libraries that help us to build and train deep learning models with the minimum efforts. And finally, we will move to a practical case study where we will use deep learnings to predict diseases based on patient symptoms. And we will train and test the models. And if someone wants to join on the hands-on, they can do parallel to us. Now let's recap our concept that we discussed in our last webinar about how machine learning works. It has two main phases. First one is training, and the second one is interface. In the training phase, we simply just give machines a data set that includes the both input and the answer against that input. Here I'm talking about the supervised learning because last time we discussed in detail how the supervised learning work. And after that, the learning algorithms study the pattern and identify the insights from the data, and at the end it's create a train model that understand how the input connect to the outputs. In short, it's identify the relationship between the input and the output variables. But in the interface phase, we give the model new data, and this time we don't have the answer because we are predicting the future on the base of our already trained model, and that new data feed to the trained model, and it start predicting. And we use this type of trained model in our real time applications. Now let's take a look at a different type of machine learning. There are three main types of machine learning. First, we have a supervised learning. I will briefly explain them. In supervised learning, we just give a label data to the model, and the model can extract the useful information with the help of label data. For example, we have the data, and on the same data, we also have the label, like we have the question and we also have the answer, and machine extract the information with the help of both input and output. But in unsupervised learning, where the data has no labels and the model find pattern on its own. And the third type is reinforcement learning. This is based on trial and error, where the model learns through reward and penalties. Here, each type has different uses, and we choose based on the kind of problem we're resolving. And now, in today's session, our focus will be only on supervised learning, as we can see in the slides. And supervised learning has two main types. The first one is classification, and the second type is regression. And I will explain both in details in our next slides. But here, I want to highlight one important thing. As we know, as even we can see in the slides, all the algorithms have different applications. Like if we will see the classification and regression, we will see image classification, customer retention, fraud detection, forecasting, and many more. So the important point here we need to know, these choice between classification, regression, or some other algorithms depends on the problem that we are going to solve, and we have to decide it in the beginning of our project. Now let's compare the two main types of supervised learning. As I mentioned, classification and regression. Actually, these both are used to make prediction, but type of prediction is totally different. Regression is used when we want to predict continuous quantity. For example, you are going to predict the price of house based on the available features. For example, a house have one features is size, location, and maybe the quality of the house. But on the other hand side, we have a classification, and we use the classification when we want to predict the categorical data, or when we want to predict the yes or no answer. So here I want to convey one more concept. If we want to predict only two types, for example, in this slide we can see we want to predict email is spam or not spam. So here we have only two options. We want to predict email is spam or maybe it's not spam. So it's a binary classification. But if we will have more than two classes or more than two options, we will say that this is multi-classification. I hope you will remember this concept because we will use this in our practical session. Now let's understand the linear regression first. Actually, linear regression is used to predict the number based on the other information. Normally, we call the number we want to predict is a dependent variable, and usually we represent with the y. And all other information that help us to predict that dependent variable is the independent variable. Here, it's written as x. For example, if you want to predict I'm sorry. Okay. For example, if you want to predict the monthly sale, we might use the advertising cost as the input. So here the idea is to find the straight line, as we can see in the slide. Like this straight line is the relationship between the two variable, dependent and independent variable, and the goal is to to identify this fit line. And here, if the output is the number like price, age, temperature, then the linear regression is the good model. We cannot use the classification here. So here we can also see the equation y equal to b naught plus b1 x plus e. I want you to emphasize on this equation because we will use this equation in the neural network, and then you will understand why the neural networks are best as compared to the linear regression. So let's break down this equation here. Y is the dependent variable, x is the independent variable, and b naught is the intercept, b1 is the slope, and e is the error. I will not go in detail how this linear regression work because our focus is more on the neural network in today's session. I think it's not working. Okay, now let's look at the second type of supervised learning, that is logistic regression that we use to solve the classification problem. So now here we need to understand one very simple concept. If we're going to solve the regression problem, we will use the linear regression. But if we will use the classification problem, then we have to use a logistic regression here. So actually, logistic regression is used when we want to predict categoricals or categorical variables that are not numbers. For example, predicting whether a student will get admit or not, or whether a patient has a disease or not. So these are the categorical variables. So in this case, the output is a label like yes or no, or we can say that this is a 0 or 1. So we have to make the decision between the two variables that are the categoricals. So just like the linear regression, we still use input variables that is called x, and the goal is to understand how those features affect the outcome. But instead of drawing the straight line, logistic regression use a curve. We can see here the S shape that is showing in the graph. That is showing the probability between the 0 and 1. So if the probability is more than 0.5, we will say that the answer is yes. But if the probability is less than 0.5, we will say that the answer is no. We can also change the answer in the 0 or 1, or we can also create some options. Again, it is depends on the our project's objective, what we are going to do. And here we can see the equation that we normally use in the logistic regression. It's very simple, like log into y over y minus 1. Actually, this show the log odds of event happening. Basically, the chances something will happen versus not happen. So we can identify with the help of this equation. And on the right hand side, we can see c plus b1 x1 plus b2 x2 and so on. Here the y is the probability, x1 and x2 are the input features, and c is the intercept. Actually, this formula helps us to model turn into features into the probability, which we use to make final yes or no decision. Let's look some examples to understand when to use linear or logistic regression. If we want to predict something like a monthly sale based on advertising cost, we will use the linear regression because the output is a continuous number. On the other hand side, if we want to predict whether a student will get admit or not based on their CGPA, actually in this table, we can see the 0 and 1. Actually, this 0 represent the no and the 1 represent the yes. On other cases, 0 means not admit and 1 means admit. So the rule is very simple. If the output is a number, we will use the linear regression, and here the number is a continuous number. And if the output is a category, we will use the logistic regression. Okay, so as we know, today our main focus is on neural networks. So at this point, I want to bring your attention to deep learning. I hope you all are familiar with this word. Actually, because neural networks are the core building blocks of the deep learning, not the machine learning and the artificial intelligence. So to understand where deep learning fits, let's take a quick look at this bigger picture. Here, I just want to show machine learning is a part of artificial intelligence, and deep learning is a part of machine learning. Here is the detailed comparison between machine learning and deep learning. Actually, I want to focus is because when we will start the neural network, then you have to clearly understand what are the clear difference between the machine learning and deep learning. Some people think that these both are same, but actually these are entirely different. So, machine. Let's start with the definition first. Machine learning is a part of AI that use mathematical, or sometimes we can say that it is a combination of mathematical and a statistical model that used to learn for data and improve over time. But in deep learning, this is the part of machine learning, but we use the neural network with many layers to learn from data. And now let's look at their approach. Machine learning used the algorithms to find patterns in data, but deep learning automatically extract the pattern from the raw data. And when it's come to the feature selection, as I remember in our last webinar, we discussed about the importance of the feature extraction. Here we can understand in the machine learning, we have to manually select the features. We have to do it by our hand, but in the deep learning it will automatically select the right features. So in the simple word, if we want to identify the correct feature in the machine learning, we have to do it manually. For example, if I have one object, like this is a bottle, it have various features. For example, it have size, it have weight, it have a color. So which feature is important in the machine learning? You have to decide by manually, like which is an important feature. But in the deep learning, it will do automatically. And machine learning models can usually run on the standard computer, but for the deep learnings, we need powerful systems like GPU to handle the heavy calculations on large data. And one more important thing, you have to understand this: machine learning can work well when our data set is smaller, but deep learning need a large amount of data to perform well because the model are more complex. So here, before I move next, I have a quick question for you. uh, how do we know if our data is small, medium, or large? Okay, you can try on searching on Google, and you can type your answer in the chat, so I will get know. People are not sleeping here. And I will try to answer that question. So let me repeat my question again. How do we know if our data is small, medium, or large? Okay, let's move forward. So this is our main part, neural network. Let's talk about it. Actually, neural networks are the heart of deep learning, and these are the building blocks of the deep learning. So let's start with the simple definition. Neural network is a series of algorithms that endeavors to recognize underlying relationship in set of data through a process that mimics the way the human brain operates. So in simple word, a neural network is the model that help machines learn from data, and it work in a way that's similar to how the human brain works. And one more thing that we need to understand here: neural network is series of algorithms. So this is not the single algorithms. It is the combination, or we can say that the multiple algorithms connect together and make a very big network. And these algorithms are built from small units called neurons, and each neuron does a small task. And when we connect many neurons together, it becomes a big network. Here we can see the typical biological neuron, and in this diagram, you can identify some main parts. For example, we can see the dendrites, we can see soma, sometimes we also call it cell body, and cell body have the nucleus. And after that, we have axon and axon terminals. And we can also see the myelin sheets here, that is the thin layer on the axon. Actually, this layer is just protect the electrochemical signals when it's transferred from the soma to axon terminals. Let's try to understand how it's work. Very simple. Dendrites receive the information. We can say that dendrites receive the input from the other neurons, and that neurons pass that dendrites pass this information to soma, which is also cell body. That cell body have the nucleus. Actually, nucleus is the central processing unit of this neuron. We can also say that this is the brain of the neuron. And after that, the process information pass to the axon terminals with the help of axon. And here, the myelin sheets protect that electrochemical signals. And here we can see one more thing. All axon terminals connected to the dendrites of the other neurons. So we can say that one neurons connected to the thousands of other neurons and providing the input to others. So here I would like to share one more information. It is said that a normal human brain have 86 billion neurons. So each neuron is connected to the thousands of the other neurons. So we can assume how big network is in our brain. So now let's look at how we take the idea of biological neurons and turn into the simple mathematical model that a computer can understand. So in this model, the input value are called x. All the x you can see in this figure, these are the input values, and these input values connect to the neuron, and we can see the W1, W2, and so on. These are the weights, and these weights are actually telling us how important these input values are. And we can also see the B, that is a bias term. We can say this is the array term. Actually, this is also playing a very important role when we make the big network. And all this information that is connected to the neurons, then it's combined together and passed to a function, and that function sometimes called threshold unit, sometimes it's called transfer functions, but most of the cases it's called activation function. And here equation number 1, we already familiar with this equation in a linear regression. The thing is, this equation is linear equation, but we claim that neural networks are not limited to just the linear pattern. So why we are using the linear equation? How the neurons convert the linear to the non-linear? So here the activation function playing the important role. If you will see the equation number 1 generated by the neurons, this equation passed from a function that is called activation function and convert it to the non-linear, and that is a more realistic pattern in nowadays and in real world. So here some of the famous activation function nowadays we are using. Actually, we have a lot of activation function. Again, it depends on our problem, what we are going to solve. But we can see 3 activation function here. First one is sigmoid, very famous, and we will also use a sigmoid in our practical session today. It just convert the values from 0 to 1, and in 10 it's convert the value from -1 to 1, and ReLU is convert all negative value to 0, and it's stay with the positive value as it's get from the neural network. Okay, so now let's have a look on a structure of the neural network. Here we can see a complete structure. The first part of the neural network is called input layer. Actually, here we can see some values x1, x2, and so on. These are our data features. It also depends on what problem we are going to solve. If our data set have 136 or 150 features, then the count of these neurons will be 136 equal to that data. So now you should understand what are the count of this layer. So the total number of the neurons will be equal to the feature size. And the next part is hidden layer. A neural network have one layer, or sometimes it have more than one layer. So it depends on, again, our hyperparameter tuning, and normally we use one layer, but we can also use the multiple layers. So actually this is the main part, and here actually learnings happens, and it identify the patterns with the help of the multiplication with the weights and the biasness. And the last part is our output, and in this part all the information received from the hidden layers convert to the useful information. If we are solving the problem that is related to the regression, it will convert to the regression threshold. But if we are trying to predict something that is categorical, it will give us the answer accordingly. And here again, we can see the W, K1, K2, these all are the mathematical values that give us the information about the importance of each features. And we can also see the BK here, and BK is the bias value of K neurons and so on. Okay, here I would like to explain the very important concept, backpropagation. If the information pass from input layer to output layer, the flow is called feed forward. But if the information travel back to the input layer, it's called backpropagation. Why we need it? We have to understand this in the simple way, because we are predicting something. So anything will come to the output layer, we have to accept it. But the problem is, because we are trying to solve the supervised learning, we already have the answer. So in this case, we will match the predicted value with the available answer, and we will calculate the error. And once we will get the error, we will throw that error back to the previous neurons, and that neurons will understand, okay, this is a mistake, I have to update my values. This is same like you are submitting something to me, and I already know the answer. I will mark it and return back to you. You will understand this is my mistake, and next time you will improve it. In the same way, in the backpropagation algorithms, the network update its value continuously until we get the exact answer. So this method is called backpropagation algorithms. And here I would like to raise one question. Like we already understand this is a structure, how the information pass. But is it easy to manage all the iterations? How these neurons know that how much weight we need to adjust? So here the gradient descents come in the picture. Actually, if you will see in this picture, gradient descent will tell the neurons how much weight it needs to update. So in the beginning, maybe it starts from a very high value. You can see the red region, and these red regions means very high loss. Loss, I will refer the error in the information. So slowly, it will take some step, and it will go to the global optimal solution. And the global optimal solution will be the lowest loss of this neural network, which will give us the highest prediction according to our problem. And we normally use this generic equation, theta I plus 1, which are the new parameters, and theta I is the old parameters. And here, one more thing, the learning parameter, or learning rate. So learning rate normally tell us how big step we want here. If we will use the very big learning rate, maybe sometime we will mislead the optimal solution. And if we will use a very small learning rate, so in that case, maybe we will not reach at the optimal solution. So that learning rate we need to decide very carefully. And we also say learning rate as a hyper parameter. The developer know that how to set it. And we also have some libraries that can automatically update the learning rate according to the iteration. So the main concept is we try to find the global optimal solution that give us the least loss in this network. So we will predict the best prediction. So now let's quickly talk about the optimizers. Now we already familiar with the gradient descent. Actually, optimizers are the smartest versions of the gradient descent. They make the learning process faster and effective. Here I mentioned some optimizers like gradient descent, stochastic gradient descent, mini batch, momentum, RM, RMS prop, and Atom. Atom is very famous nowadays, and we will also use the Atom in today's session. I'm not going in detail how they work, but one thing is very clear: these all have a different characteristics, and also it will connect somehow on our objective, what we are going to solve. But I think at this moment we have a limitation of the time, and but we will discuss in future if we'll get chance how these are different from each other. Now let's move to the some popular Python libraries that we will use for deep learning, and these libraries help us to make our model with minimum efforts. For example, if you will start write code for a neural network, maybe you will spend 1 a day, 2 day, 3 day. because this is very complex structure. We cannot easily handle it. But Python libraries, we have Python give us a lot of libraries nowadays that can give us the ready-made function. We just need to give the instruction to that libraries, and that libraries automatically can generate the neurons and the structure of the neural network. So nowadays the things are very simple with the help of the libraries. The first library that is very famous nowadays is TensorFlow. This library was developed by the Google Brain. This is a powerful and widely used in both industry and research. The second library is Keras. Keras is a high-level library that run on the top of the TensorFlow. This is simple, and if you are beginner, you can start with this library. This provide a lot of functions and inbuilt variables that can change the functionality of neural network easily. Next is the PyTorch. This one was developed by Facebook Artificial Intelligence Research, and it is also very popular in the research community. Actually, there are many other libraries, but these three libraries, TensorFlow, Keras, and PyTorch, are the most commonly used in deep learning. Okay, so now let's look at case study where we will use the neural network to solve the real world problem. Actually, here our goal is to predict disease based on the patient symptoms. So we will use a data set that contain around 5 to 6,000 patient records. Each patient record have 132 symptoms, and these symptoms include like itching, skin rash, vomiting, headache, weight loss, and so on. So total size is 132 in this data set. And on the basis of the symptoms, our target is to predict the disease that is based on that symptoms. And that we in this data set we have 42 diseases, and our model have to predict the best disease. I will not say the best, but our model will tell us what is the disease on the base of the patient symptoms. And the possible disease can be allergic, diabetes, migraine, hepatitis, thyroid, and so on. So in this mini project, we will build a deep learning model that will train our patient symptoms data. And after that, we will see how well it can predict the correct disease. So now I would like to request Tariq to first show us the data files that we will use in this case study. And after that, he will show us the model development and training process. And if you want to do the coding parallel, you can do. But if you are not interested, you can just see and you can do it later. Okay, so over to you, Tariq. Thank you.
Thank you, Dr. Adil. Thank you so much. So let me start with the data first. I will try to show the data in Excel first, and then I will show the same in Python as well. So this is our data. As Dr. Adil said that we have around 132 symptoms. So these all are the symptoms. And then at the end, we have the disease, which is like these are the actual disease based on these symptoms, and they are recorded by some doctors. So in the data, we can see, like, for example, if a patient have a certain disease, it will be marked by one. Sorry, if a patient have certain symptom, it will be marked by one, and if he doesn't have that symptom, it will be marked by zero. So all this data contain like 1 and 0, 1, 0, and this is a classification problem. And just like Dr. Adil mentioned that in classification we have to classify whether this is yes or whether this is no. So for yes we are using 1, and for no we are using 0. And just like Dr. Adil mentioned, we have around 142 disease and 132 symptoms. So let me now start with the coding part. Yeah. So we will start by importing some libraries. The library which we need for our model development, data pre-processing and testing, and at the end some prediction, a small app which I have developed, and we will give them our symptoms, and it can give us the disease based on the trained model. And if you want to try it yourself, you can use Google Colab. If you go to Google and type Google Colab, and then it will show you a notebook, and you can just start typing the code. You don't have to install anything or do anything, just start coding over there. So let's start with importing the libraries. I have already typed the libraries because sometime it takes some time to import the libraries as they are very big libraries. So I have already run this code. Here you can see that I have imported a lot of libraries. First two libraries are for data manipulation. Like you can use these libraries to import data, to visualize the data, and to use them for some data cleaning and some missing values and things like that. Then I have imported the TensorFlow. So you can see this coding, the structure of this coding is basically like the way Python work. First, I import that library and I name it as like TF. I can name it anything. I can name it, for example, TensorFlow library. But later on, I have to use this full name in order to call this library for some specific function. So as a convention, or you can say as to be easy, we just write it as TF. Other coders also use almost the same convention, and if you show your code to someone else, they will understand which library he is using. So this first one is importing the TensorFlow library, and then from TensorFlow, I have connected it with Keras and imported our model, the sequential model, which I will develop the neural network and some other layers to develop the different neurons layers. And I have also imported some other um, libraries for data labeling or encoding and splitting the data and some classification reports and for plotting and for making some graphs and some like visually appealing plots. I have imported some additional libraries as well. So now let's start with the data preparation. In data preparation, we actually first start with loading our data to our Python interface. So let me quickly do it. I will name it training data pd dot. So I'm using the pandas library and read. My data is actually CSV file which I showed to you, and the name of the file is training.csv. So now if I run this part, it will import that data for me. And if I want to visualize that here in Python, I can either write print train underscore df, and it will show me all the data here. Print is my favorite command, so I will use it a lot here. So this will show me all the data, and it's very big. We cannot visualize it. It show me some rows, some columns. In order to just check the headings, I can modify it a little bit. Like say, give me just the heading, and if I print it, it will show me around like the first 5 rows. And here you can see it has imported all the data. So now let's do some visualization also, or maybe we can check for uh, some uh, some null values or some other empty values, missing values. So let me quickly use again the print command underscore df dot is null. So it will basically go through all the columns and check if it has any empty values. And so now it give me the heading of the column, and it says it doesn't have any null value. So our data is very good and already clean. We don't have to do any cleaning or something like that. Next, let me visualize it a little bit, plot a graph to show like how many diseases we have and what are the count of each disease. So let me quickly create a plot here. You don't have to remember these coding. I also don't remember. If you need any help, you can ask ChatGPT, or, for example, if you want to use TensorFlow library, just do a Google search and it will give you very good like code or existing code or with some example how to use it. So my Y column is the prognosis, which are the diseases, and I want to uh, like count how many data set I have for each disease. So I have added some data to my plot, and then I will give some title if I want. You see, it's like also very intuitive. You can guess what the coding can be. For example, like for title, I just type dot title, and you can give it title, maybe disease count, something like that. I can also label the x-axis and y-axis. But as we are doing coding, so like we have to give every detail of the plot. If I don't give them, it will just label nothing or show me some error. And so I have created my plot, and now if I say plot.show, it will show me that plot if I didn't make any mistake. Yeah. So this is like the disease count. I have the disease and I have around 120, more than 120 sample for each of them. So this is a little bit visualization. You can do some advanced visualization as well, and you make a histogram or many kinds of plot. Like Python has a lot of variations and a lot of variety. Whatever you want to do, you can do many things. So now let's move to the second step by building our training model. But before that, let's maybe do some encoding, because as I show you, like the diseases in our data set, they are the names. So AI cannot read the names in the form of words. So we have to do some encoding. Like we can represent each disease with some number. For example, we have 42 diseases, so I can assign a number to them like 1, 2, 3, 4, 5, and then Python will, sorry, the AI model will predict those number, and we will do the decoding and know that uh, which number represent which disease. So let's do some encoding first. I will create a encoding here. And as you remember, I already imported the encoder at the beginning. So I created this encoder, and now I will assign it to um, my my disease values, because already the other columns are already in numbers 0 and 1. If some were not numbers, we would have to convert those as well. And when you are doing coding, nowadays you may know that it's very easy, but if Python is very sensitive to these names and these kind of things, so you have to like correctly name them, use proper like capitals or small words. But if you make any mistake, it will let you know and you can fix that very easily. So let me print here the to show you like how it looked like before doing the encoding. So my y-axis is currently shown like this. It show me the disease names. And after I do the encoding, let's see how it looks. So you see now it has assigned numbers to all of them. So this is the encoding which I have done here. Now what I will do, I will create my training data set because I want to train my model on that, and the training data set will be like all the x-axis, not the y-axis. The y-axis will be my my y train, and my x-axis will be my x train. So I let me split between x train and y train. So x train will be equal to training my total data set, and I will drop the y-axis. Similarly, my y train will be my total training data set equal to the y-axis only. If you feel like I'm moving very fast, you can stop me or tell me to slow down. So you see, I'm now creating the X train or Y train, and you see, I made a mistake, so it has directly given me some error that this is not found. I think I made some spelling mistake. Let me correct this.
Can I ask a stupid question?
Yeah, sure.
So the last code, right, where you're isolating the X and the Y to train, like, what are you trying to train?
I'm actually like I will give this X train and Y train to the model. So what model will do? Model will check the X train and try to learn the patterns in that and try to predict the Y value.
Okay, may
But
I
you
answer
drop
this?
Y, right? So how can it?
May I answer
Yeah.
this question? Okay, in the supervised learning, as I mentioned in my presentation, we have data, we already have the symptoms, and against that symptom, we have disease. So we already know the answer. But in the training, we will not show the answer to the network. We will let the network predict the answer, and after that, we will match. So here, he just separating two things. So he is hiding the answer from the neural network. So neural network will automatically randomly predict first, and we will match with the answer. We will calculate the error and bring the error back. Yeah, that is.
Thank you.
Okay, let me try again. I think I made some mistake in spelling. Oh, sorry, I have to mention the access as well. Okay, so now I have split the data into training X and Y. Now the next step I will do is to like select some data for training and some data for testing, because we don't want to give all the data to the model. In that case, it will learn the on the old data and we will not have a testing data set. So let me create a uh, testing and training data set from the same data. So I will let me rename this one because it will have the full data, and then X train, comma X test, and Y train, comma Y test. So as you remember, in the beginning, I imported the splitting library package also from the library, and I will use my X, comma, and I will specify here what my test size will be. So let me select like 30% for testing and 70% for training. So I will write here 0.3. So it will take out like 3% for 30% for testing. Now, if I want to just quickly check like how many samples I have selected for testing or training, I can just print xtrain dot shape, and it has like 3 4 7 3 rows for the training, and if I replace it with test, around 1500 for the testing. Okay, so this is my part for the data pre-processing and preparing the data is completed. I have already the test set, the training set, y test and everything. Now I will go to creating the model. So first of all, I will build my model and then I will train that model. I will create some layers and things like that. So let me first of all get my my features from my data, the size of my data, because that size I will use in creating my model, because my model will have a number of neurons. So I have to like combine them with the number of features I have in my data.
Add one things here.
Yes.
So here you can relate this thing. As I mentioned in the neural network, first layer, we need the feature size. So here our feature size is 130 something. So we need the neurons according to the feature size. So that's why he's taking the quantity of total neurons and he will pass to the neural network. So that's why we have to match everything according to our data now.
So here I have I got the number of features from my data and number of classes as well. I already know that they are 42, but just to be sure, I use my encoder to give me the exact number of classes so that we don't make any mistake. Now,
Very quickly. So, features are symptoms and classes are disease, or
yes,
okay.
that's right. So now let's create a model. I will name it as model. You can name it anything, and I will use my sequential package that I imported to create my model. Okay. So let me add the first layer. We call it dense for the deep neural network. And I can start with any number of neurons. I can start with 64 or yeah, let's start with 64, and I will use the my features as my input dimension. Like I have 132 features, so those 132 features will be equal to the number of neurons, or maybe the product of number of neurons, so that they are connected by the accurate weights, just like you saw in the figure. So let me make it equal to this one. Now there is another thing which I want to mention here, like the AI is very good in, even like if it doesn't learn the pattern in the data, like our data will have some patterns, it will have some specific like shape it follows. So the sometime the AI doesn't learn those shapes on those patterns. Instead, it learn the whole data. Like it know from the whole data that if I have this system, these symptoms, these will be the disease. So, in order to avoid this, to just to understand the data or learn the whole data, I will try to force it to learn the patterns. So for that, what I will do, like I will use another layer here, which we call as dropout. So in that dropout will help me to stop some neurons from working in some iterations, and some others will be working. So this is a strategy developed by researchers in order to force the model to like learn the patterns and the data structure, something like that. So in initial layer, I use the activation function as ReLU mentioned by Dr. Adib. I will use the dropout of 50%. Like I will make it force to not use 50% neuron in some iterations. Now I will create another layer with 32 neurons, and I will again use ReLU function as activation. Now, if you want to like know what other functions I can use or what other options I have, you can just go to Google and search like TensorFlow activation functions or TensorFlow optimizers, things like that. It will help you a lot by deciding how many activation function you have and which other you want to try. So in the last layer, we will use the sigmoid, because our data is first of all categorical, and then we want to decide like which disease we have and which not. So this is a very simple model I have created. So let me run this. Maybe if we have some error. Yes, yes.
Sorry, I keep disturbing you.
No.
And this might be a stupid question. So the layers, right? So in your presentation, you had like one layer, second layer, uh, and that layer is to identify patterns. It's interaction between the variables, and then ultimately see the pattern, right? And here you're trying to force the model to learn the pattern. Um, and you're putting conditions there, right? So the pattern that you want the AI to learn, is it dictated by the data itself, or is it your prior knowledge about the disease or the interaction of whatever you're trying to learn? Which one is it?
Yes, okay.
Okay. Basic concept is the basic concept is these all things that Tariq is doing. These are the hyperparameters. It doesn't mean that it will work best in this case. We can change it, and it also depends on the developer how he mentioned these layers. You can see we have a lot of hyperparameters here. We can change the values. The thing is, we want to create just the network, and when the information pass from the networks, it automatically detects some values. And when values pass from one neurons to other neurons, it will give us some weight. It will give some biasness. And when the value will reach at the end, we will come with one pattern, and that will be automatically detected by the network that we create. At this stage, we don't know what will happen. We are just trying first, and slowly we will improve.
So now let me check the model summary that we have created. So do you guys have any idea like how many parameters does the large language models like ChatGPT or Gemini have? Yeah, they are like in trillions. Like the latest model of Grok, ChatGPT and Gemini, they exceeded the parameters in trillions. So now let's see how many parameters our model we have that we have created. So I will use this model summary command, and if I run it, you can see we have from the first layer we are getting 8,000 parameters and 2,000. So in total, like we have around, I think, maybe 11 or 12,000 parameters. Yeah, so
By parameters, what does it mean in this context?
by parameters, like it will combine the number of neurons, multiply the number of neurons with the number of features in my data. So it's like you can say that it's the size of my model, the size of the neural network which I have created. So in our data, we for our model we have just 12,000 parameters, and imagine ChatGPT have in trillions. So what will be the size of their model? And how much time it will take for training and so many others, like storing the data, and even the model is very big. So this was just for to get the perspective. So I have already created the model. Now let's train the model. I will use the compile command for training the model. Sorry, compile is used to define the optimizers and things like that. We will use Adam optimizer, and I will define some loss function also. Let me copy this function name.
Question on this one.
Yes.
So the graph you showed earlier, right? The gradient one.
Yeah.
There was the learning rate, and then there was the loss, right? And but you said like you choose the learning rate. I was for me it's counterintuitive, because like when you're like you test the model, and then the model should give you like what is the learning rate of that model, but here you're already specifying what the learning rate should be.
Okay, we have two things here. The one thing, okay, we have two things here. One thing is like our concern is to understand what is the learning rate. Okay, in the training, we are not just passing information just single time. Maybe we will pass thousands of time to understand the pattern. Sometimes maybe more than thousands time. So learning rates need to understand what is our loss, and that loss help us to improve iteratively. Here he is using the Adam. So Adams can automatically detect how much learning rate he have to adjust. Is it correct, Tariq?
Yes, but we can force it also.
But
Yeah.
we have the options here. We can set the learning rate by ourselves as well. So we have two options. We can allow the system to automatically adjust it, and we can set by manually. So if it will do automatically, this will be more efficient and more optimized because it will do some calculation before deciding the learning rate. Normally we use 0.001 or 0.01. So if it will do automatically, it will be very efficient. If we will do the manually, maybe our result will be not good. So this is a part of Adam, the optimizers. Yeah, we already see in the slides like why we are using this, just to make it efficient. Yeah. Is it any more comment?
No, yes.
I hope you clear.
Yeah, don't let me be the only bad guy. Na? You guys can ask questions and people online too.
It's good. Like now we are on the right screen. Like people
Yeah.
are understanding at least.
So here I have compiled the model, like giving it the Adam optimizer, some loss function, and some metrics, like based on what metrics I want to compile the model. For loss, we have some other parameters also, like mean absolute error or mean square error, and many things. You can find them in the TensorFlow library, which one to use.
This is just for the comparison.
Yeah, just
purpose. So this is just for the comparison purpose. After calculating the loss, the model will know what he have to adjust. Sorry, what it have to adjust. So that's why we can here. I think Tariq is using just one type, but we have a lot of other options.
Yeah.
We can modify it.
Like for example, when I train this model, we will get some accuracy. So in order to increase the accuracy, we will try some other maybe change the model size as well, maybe change the parameters and see how it affect the training process. So I will now when I type this fit, it will basically start training the model. So I am giving my training data and my X train and my Y train to start the training. I will define some episode like epochs, like how many iterations should the model run. Let me select 50 iterations and then the batch size. So what the batch size is actually like the model will get a small batch, uh, like batch of 30 examples or 10 examples to train the model and check the accuracy. Like it's back propagation. So it will check and go back and see the result. Then train another 32 and check the results and another 32 and check the results. And it will adjust the weights of the neurons. So let me run this one and I am saving this in the history so that I can plot the results as well. Yeah, so you see here the training is started now. And here I can see the loss function, the accuracy. You will see that the accuracy is increasing and the loss function is decreasing as we are moving iteration by iteration. So like it's an initial good indication that our model is going in the right direction, and at the end you see we got around 83%. Yeah, and loss is like 48%. Maybe not good. It should be around 98% or 95 or 96%. And this one should be around maybe less than 10% or 5%. So let's change the parameters of the model. Let me make it increase the size of the model.
Okay, while you do that, can I ask Adeo about the weight of the neurons? What does it mean? Yeah.
Weights of the neurons.
Yeah, weight. Like you said, you give weight, and it automatically gives weight to the each neurons,
Yeah,
right?
yeah.
What
Okay,
does it mean?
actually, in the simple words, let's try to understand what is the learning in neural networks. So, in the neural networks, because this is a combination of the weights, and at the end, it will multiply that weights with the features, and it will predict something. So, basically, that's weights are our learning. So, in these iterations, every time it's update the weights, but that weights updation is not random. It's based on the previous iteration. So when the iteration start, we will get some weights, and that weights will go to the next iteration, and slowly, our accuracy is increasing, which means that model is predicting the right answer, and our loss is decreasing. So this is the mechanism behind this. So now Tariq is doing the hyperparameter tuning because it is showing just 83% accuracy. 83% accuracy means that if we have 100 samples, so only 83 times it's giving us the right answer. Other time it's predicting the wrong answer. So that's why we have to recheck again. We have to retrain again. So now these all steps are the part of hyperparameter training. We are doing the we use one term hit and try, and here we can say that okay, we will change something and we will check again, maybe we will get the better result. We also have some applications for this purpose, but it would take too much time. Maybe sometime we run our computer for months and more than months as well to just do this hyperparameter screen. But here Tariq is doing just the manually. He will change some parameters and try to get the better result. Especially when we work on the medical field, we cannot tolerate with the accuracy. We at least need 99% accuracy. Of course, we will not get the 100% accuracy because this is a prediction, but we cannot tolerate the error. So here we are just getting the 83% accuracy. And as you know, our data is related to the diseases. If a doctor is predicting the wrong disease, obviously this will be very bad for the, yeah. No?
Yeah, I think.
Can you please?
Let me answer. I think you asked about the weights, right? So weights are similar to you have seen the statistical equation of y is equal to c plus mx, something like that. So in that we have that the slope and that intercept. These are actually the weight of that equation. So we have similar weights in our neural network also. So what these the adjusting the weights or learning the weight is just fine tuning those to like accurately follow the pattern or learn the model pattern or the data patterns and things like that. Yeah, exactly like that. It fits, try to fit the data, you adjusting the weights. So here I have increased the size a little bit. I can change the activation function as well, but let's stick with this one for now. Let me quickly run this now again. And let's see how the accuracy changes. Now you see it even after the fifth iteration, it went to 90% accuracy. And you see now at the end, we are getting very, very close to 99. Yeah. Yeah. It's very good now, I think.
Yeah, it's showing the 99.
Yeah. So let's now do some visualization. I have already write the code because it's very lengthy. In that, I'm trying to find the learning curve, like how the learning started at the beginning and how it ends at the iteration, and we can get some good insights from that as well. So let me run this code. So this is the accuracy, like how the accuracy was increasing with iteration and how the model loss was decreasing. So can anyone tell me what insights can we get from this, uh, these curves?
My guess, no. So EPOS are your batches, right?
Yeah, these are like the episodes
Yeah.
of the you can say iterations.
Yeah. So, in your first iteration, the accuracy was like 0.25 something, and then very quickly between maybe like fifth iteration, the accuracy suddenly goes to like 0.95%, and the same, the opposite trend is for like the loss.
Yeah. So one that was also a very good insight from the figures. And another thing we can get is like, yeah, that flat. That's very important. Like even if I do 30 iterations, I will get the same accuracy. You can see after 30, it flatten the curve. So this is very important if you have very big data and very uh, you try to save energy or cost, because of course it will running your CPU and it will cost you something. So
So basically, after like 30, there's no point doing
Yeah,
anything,
yeah, yeah.
right?
No point
So,
in
yeah.
doing that.
And let me add one thing here. This is very ideal case. Normally, when we because our data is already pre-processed and clean.
Yeah.
So, but in the normally when we work on the projects, we cannot get this type of curves. We have to struggle.
So now let's move to the testing part. Like I separated some data from the for testing, and the model has not seen that data. So let's try to do some testing. Model.evaluate. So I will use here X test and Y test, which I separated in the beginning. And let me, okay, where did it go? Print loss. So this is loss. Loss is also very small. Like this means that like 10 raised to the power 6. So like 0.0000272 something like that. Same for, let's see the accuracy. Accuracy is like 100% for testing.
So here, like what we are trying to do, we are giving the new data to the trained model.
Yeah.
In the training, it was showing the 99% accuracy, but now we have to evaluate on some other data. So in the beginning, we already separate the data. We separate some data that was not visible to the model. So now we are giving that data to the model to understand now it predicting right or not. So what we understand here, all the sample predicting correctly by the trained model. Yeah, I hope you understand. So this is the one way to validate our model. Training is just one part, but we have to decide this is correct or not.
Yeah.
So by this way we can do, because we already know the answer of the testing data, because this is also the past data. Yeah. So now we can use this model for the future prediction because we already know this is working fine.
Yeah. So up till now, like we have already trained the model and we can just deploy this model after this. But if we want to do some further analysis, maybe check some, we call it confusion matrix in classification problem. So let me quickly generate some. Let me, yeah, some confusion matrix in order to check like because in our training we got around 98% error. So let's see how the model gave that error and for which data point. So this confusion matrix actually like show us the actual diseases and what the model predicted for those diseases. So you can see here this diagonal values means that the model predictions are same as the model actual values. The model predictions are same as actual value. So in our training data set for this specific disease, we had 36 data points and the same was predicted by our model, and almost for all of them like our model predicted accurate values. So this confusion metric is like you can say another layer to confirmation, confirming that our model is predicting accurate values and it is performing as expected. So once we are satisfied with all the analysis and all the training and the accuracy, the next part is to deploy this model to so that some other users can use it and they can get benefit of this model that we have trained. So for that we usually create a small app and we deploy them on some website, and in my case I have created a small app, but I will show it over here to you that how it look like. You can change its GUI as it suits you, and I'm getting some error. Let me correct it. Yeah. You can change the GUI as it suits you. I have created a very simple GUI. Where is it? No, no, it will be here in the same view. Sometimes this notebook have this problem with the GUI. Let me show you the other one which I already created. Yeah. So let's predict some, if anyone have any symptoms, they can tell me and let's see. Yeah, you can see it, right? So this is a small app which I created. You can let me know your symptoms and we can predict what disease you may have. Anyone want to try? Like we want to have to like predict actual disease, you know. Yes. So okay, one symptom is anxiety and one is back pain. Any other? Migraine. Does it have migraine? Headache. Maybe headache.
Yeah.
And what else? Okay. So let's predict the disease. Yeah, so now good thing is that it is giving me actually the percentage. Let me, yeah, you see, so it giving me the percentage, like is it 95% possible that it is this disease? I'm not good with medical terms, so I don't know how to pronounce it. The second maybe 86%.
It's a bone.
Oh, okay.
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 The first one and the fourth one are both disease.
I see.
Second and third is cold.
Yeah.
Maybe.
Mm.
Because we have headache, right?
So yeah, you see, like it can give you some. It can be a very good starting point for doctors or maybe for the reception staff to recommend the doctor to you. Yeah. Yeah.
And this is based on a very small data set, but in the actually we need a very big data for
Yeah. Yeah.
the best application.
Patient history.
Yeah,
Mhm.
exactly.
I have added this Japanese. I don't know what it means. I just it looks cool. That's why I added it. So any questions? Anyone? I think Japanese. So
If you have data,
yeah.
you need to repeat the same steps.
So we have 10 minutes, I think, for questions.
I have a question. If I want to improve my result, so I have to tune my hypoparameter, right? So which parameter should I consider first to tune it to improve my result? Because there are many like activation function, like dense unit, right? And number of hidden layers. So which one I should consider first?
First of all, you have to look at your data, okay, and you have to clean your data. Once you pass that stage, then you have to come back. What algorithm suits for your data? Now, I already asked one question in my presentation. What do you think about the small data, medium data, and large data? So, can you please tell me about your data? Is small, medium, or large?
It's small.
How do you know?
It's less than 1,000, right?
Okay,
Okay.
so it's small data. So
Yes.
for the small data, we will not recommend the deep learning. The neural networks need the pattern. I will say that we are not going for the linear relationship. We need some non-linearity in the data. So just 1,000 record, you can apply, you can check, but maybe the performance will not good. So you can go for the random forest or some other gradient boosting methods. So that was the purpose today. I mention again, it depends on what you are trying to do. So if our data set is just have 1,000 records, how we can predict the symptoms? It's challenging for the neural network. Yeah, but you can try. Maybe you will get some result, but not recommended for that. Not reliable. How you can trust? Like even for the 1,000, you have to split for the testing and training. So how much you will split? Maybe 20% minimum.
Well, how much threshold we need? How much data should we have to more time?
It should be around. If you have, this is my observation. This not exact number, but it should be around in thousands, maybe 10,000, 5,000, like this. Then you can go for the deep learning. Otherwise,
if I collect 5,000 samples,
then it can be work. But again, it will be a little suspicious.
10,000.
10,000, more than 10,000.
Like million, right? Like
Yeah.
Yeah.
Like it depends on the data. If you have more data, your accuracy will be better.
If I just take a
And-
rainfall data for 30 years, it will be around 16 GB of single files.
Yes, it's happening.
I cannot tell the exit data
Yeah.
every second before.
Yeah. So here you can see on the screen, these all are the hyperparameters. Hyperparameters means we can change it. It depends on the developer and the need of our program. And we will change it, we will check the accuracy, and we will repeat these steps many times.
Actually, you will, once you get some experience, you will know like which parameter or which activation function is the best. But nowadays, you don't need just ask ChatGPT like, this is my data and recommend me a model.
Because it seems like choosing the right model, right library is important first step. Is there any like official cheat sheet for like what kind of data fit with what library, what function,
Yeah,
guideline or something that we can use for starting?
previously, like we had this kind of like cheat sheet. For example, if your data is categorical, you can use ReLU in the first iteration, the first layers, and sigmoid and softmax in the second, in the last one. And similarly, if your data is continuous, like you are predicting something continuous, for example, your BMI or something like that, for that you can use some other activation functions. But nowadays it's very simple, just ask ChatGPT which are the best parameters.
Your logic should be very clear what you are trying to do. Okay, now you are understanding all algorithms are not same. Today we explore just one corner of the machine learning. We are not talking about the unsupervised and the reinforcement learning. And even in that corner, like I'm talking about the supervised learning, we just explored the classification. That problem is based on classification. We haven't discussed about the regression. We have different parameters for the testing for the regression problem. Different loss functions. We have that. We cannot make the that confusion matrix for regression problem. The confusion matrix is just for the classification problem. So this is very broad, but we have to understand first what is our objective and what are the right direction for us. And after that, I think nowadays we have a lot of help on internet.
Any questions from our online participants?
Yeah.
I have a question. So can you explain more about optimizer?
Okay. In words, we already know about the neural network. That is one structure. We can say that this is structure for the understanding, like the information enter from the neuron input layer, then it's passed to the hidden layer, then it's go to the output layer. And then we see one concept, the back propagation. Okay, the information have to pass back to the hidden layer, and this loop will be start. But the problem is, who will control it? Okay, I will write one loop, but that is not enough. We need optimizer that will train that neural net. It will handle everything and give us, okay, now this is ready, you can use it. Do you understand? No? Okay, let me try again. Okay, we have, okay, this is one bottle. We make it. Okay, and this bottle is for water filling. But how we will know who will fill the water in this? We need someone who will put the water in this bottle. Bottle is ready. So in the same way, neural network is ready. Structure is ready. And we know data will enter from one direction and pass from the other. But who will do it? Who will control the quantity? Who will control the quality? So that's why the optimizers come in the picture and they can control. And also we discuss about the learning rate and the weight optimization. All these things handled by the optimizers. So in this case, we use the Adam optimizers. That is a one form. We have a big list of optimizers. Yeah. So when you will play with the neural network, you should understand what is the optimizer, because that optimizer will help you to train the neural network. Neural network is just one structure. We are replicating the human brain, where multiple neurons connect together and make a big net. That's it. But the training is the main part. I hope you understand now.
Okay, I'm clear now. And one question, the epoch, like why you said 50 for epoch?
Again,
The epoch.
hyperparameter. You
Ah,
can change it.
okay.
Okay, this is my observation. I tried. Maybe my result will not good, but you have to understand what is a epoch. Epoch means that you are passing your all data from your network. That is called one epoch. For the understanding, you can say that this is one complete iteration when your complete data pass through the network.
Okay, thank you so much for our speaker, Dr. Adil and Dr. Halik. So it's such a great and engaging session. So I hope today webinar we made machine learning feel a little bit less intimidating and a lot of exciting. So we will continue exploring AI topic in upcoming episodes. So stay tuned and always remember AI is not for engineers, it's for everyone. So thank you again for joining us, and we will see you next episode. Thank you.